Hi, my energetic students. How are you? I'm sure you're all energetic about whatever competitive exams you have in your mind, JEE, NSEP, NEET, and for that you're preparing very hard. I'm back with my Noodle Chopstick series, which is not just a random name given to any series. There's a reason for that. And again, as I always say, if you want to achieve something, there's a goal in your mind, there's a numerical you want to do. There are two ways to do that. One is the Noodle way, where you're taking all this fancy route, or there is a simpler way. And that's why I call this a noodle chopstick series, where I'm saying everything can be solved either in a noodle way or a chopstick way. I prefer the chopstick way. But there are people who study who follow the noodle way and noodle method. Basically, I don't like it for reason that it's very confusing, it is lengthy, it is error prone, and it is difficult to grasp. But there are teachers who follow it, maybe because they learned it that way and they don't know there is a simpler way out there, or maybe they want to portray the concept as a rocket science. I don't know, whatever the reason, we are going to stick with chopstick because that's the easy way, and that's this series all about. My name is Bhavdeep Sethi. I've done masters from IIT Bombay. I convert physics haters to physics lovers, and I always say do not memorize physics. Physics is all over you. You study from nature. Nature is the best textbook out there. So today we are going to talk about the terminal velocity. What is this? Okay, so let's talk about parachute. You might have seen that it falls with a constant velocity, but that is surprising because the force of gravity is acting. Where there is a force, there is an acceleration. So to me, if there's a force, there has to be acceleration. So what is it about the parachute that it goes down with a uniform velocity? So to understand that, let's try to do this hypothetical question where we are saying, let's ignore air. So there is no air, and we are saying, okay, there is a raindrop that starts falling from 2 kilometers above the surface of Earth. Find its velocity while striking the earth. Very easy concept out there, I know, but this is going to be very useful to solve that question or understand the terminal velocity. So what is it about? This is about an accelerated motion where we can say utsav. So what is utsav? Utsav are the five variables in case of accelerated motion. So U stands for initial velocity. So when the raindrop starts falling, there is no initial velocity. Now it falls 2 kilometers, as in 2000 meters. So I'll not write the meter there. It's yeah, to save time. Now A is acceleration due to gravity, which is 9.8. But for now, to make it easy, let's take it 10, and we have to find the velocity, as in the velocity achieved after traveling 2000 meters. Now, relating these four variables is an equation v squared is equal to u squared plus 2as. I'm not going to spend too much of time here. This is so easy for you. U being 0, 2 times 10 times 2000. Very quick calculation gives me v is equal to 200 meter per second. What? 200 meters per second? I mean, do you even realize how big that velocity is? I mean, 200 meters every second. And there are thousands of such raindrops falling down every second. Think about, there is a car sitting on the road, and rain starts to fall down with this speed. The car is going to be just over. Everything will be destroyed. Not just the car, everything on the planet Earth would have been destroyed if this were the case. But that doesn't happen. Why? Because as it falls down, it starts to go down fast, 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 acceleration, acceleration, and then it goes down with a constant speed. So I will repeat that. When the raindrop starts falling, it goes faster, 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 and after a certain speed, it does not increase the speed, it continues with the same constant speed. And that constant speed or the velocity is called the terminal velocity. Today, we are going to study that in a very simple chopstick way. I'm really surprised when I see students memorizing the derivation of terminal velocity, and then they spill everything in exam, but still they don't understand the basics of it. So that's why I'm saying never go noodle way, go chopstick way. So let's continue. But before I start explaining anything, I'm obviously going to cover the prerequisites. So first one is, you obviously know the Newton's second law. The force applied is equal to the rate of change of momentum. But if the mass is constant, you can say F equals ma. Right? That's very useful information, equation, not information. Now weight. What is weight? Weight is basically the mass times gravity. Now, in day-to-day language, if somebody says, "Well, how much is your weight?" Some people say, okay, 50 kilograms is my weight. But no, that's not right. Kilograms is mass, that's not weight. So weight is mass times gravity. Mass times gravity, as in if this were 50 kg, so 50 times 10, that is 500 newtons. Okay, it's newtons. Newton means some force. So weight actually tells the force with which the earth is pulling an object. So let's take a simple case. Let's say there is a spherical object of radius r. So there is mass times gravity going down. So what is mass? Mass is, remember, density is equal to mass over volume. So mass is density times volume. So mass is density of this object times the volume. Volume is 4 by 3 pi r cubed times gravity. Now, by the way, I'm going to make a video very soon on how you get this 4 by 3 pi r cube. You have been memorizing it since your childhood. The surface area of a sphere is 4 pi r square. Volume is 4 by 3 pi r cube. But I mean, why is it 4 by 3 pi r cube? So we are going to do it noodle way, chopstick way, sorry. And we are going to see why is it 4 by 3 pi r cube. I'm going to show you in 3 or 4 lines to derive, to make you understand why is it 4 by 3 pi r cube. But that's later. For now, let's stick to the topic here. So if there is an object of density rho, radius r, it's a spherical body. So this is the volume times the density times gravity. This is the force with which it is being pulled down by the gravity. Buoyancy. Buoyancy is the upward force that body experience when they are in fluid. What is fluid? Fluid is something that flows. What flows? Liquids and gases. Now Archimedes came running, Eureka, Eureka, I found it. And he said the amount of this buoyancy force is the weight of the fluid displaced. So let's make it easy and simple. I don't want to damage it, but let's say I were to dip this in water. So when this is in water, it is taking up some space of water. So Archimedes is saying, if it takes up some space of water, you take that much of water, you weigh that water, whatever that weight comes out, that is the upward force. I know weight is the downward force, but let me make it clear again. So what Archimedes is telling us, if you dip this in water, it takes up room of some water, as in water was occupying some volume, and it is taking up that space. So whatever the space equivalent of water is, you weigh that water, it comes out in newtons, and that is the force of buoyancy in this case. So let's understand with that sphere itself. So there is a sphere here with a radius of r. So now this sphere is taking up some space of water. How much space is it taking up? And that much of water weight is the buoyancy force. So what is buoyancy force? Buoyancy force is equal to the weight of the water displaced. Now again, going back to density is mass over volume. So mass of that much of water is density of water times volume of water displaced. But how much volume of water is displaced? It is equal to the volume of this object. See, whatever is the volume of this object, it is displacing that much of water. It's not taking more, it is not taking less. So whatever is the object's volume, that is the volume of water displaced. So volume of water displaced times the density of water, because we are trying to find the mass of the water, the weight of the water. So I'll say buoyancy force is equal to the density of water, as in H2O, times the volume of water displaced, which is 4 by 3 pi r cubed, times gravity. So this is the buoyancy force. Buoyancy force is the weight of the water displaced. Weight of the water displaced is the density of water times the volume of water displaced, which is same as the volume of the object itself, times the gravity. So this is the buoyancy force. The last thing that you have to understand before terminal velocity is Stokes' law. What is Stokes' law? It is telling us the air resistance. So frictions, think about frictions when there are two surfaces in contact. So let's say there is a box here and there's a floor here, and you apply a force. There's a tendency of motion. So there's a backward friction force. And we always say, and we have done this many times, that the limiting friction, the friction is mu times the normal force. Normal force on this box multiplied by the mu, which tells us the roughness. So there is a friction force. But if this is falling in air, air also applies a friction force. That's a fluid friction. This was solid, solid. This is the fluid friction. So when this falls down, air says stop, 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 stop. And how much is that? That is what Stokes' law is telling us. So Stokes' law says if there is an object, spherical object, this works for a spherical object, and there's a radius r of that object. So it is saying the air resistance, air friction, air drag, one and the same thing. So it is saying how much is the air resistance? That is equal to 6 pi eta r v. Hold on, before you get scared of this and end the video, this is a chopstick method. I'm going to make it easy for you, so don't worry. So Stokes' law is saying the amount of air resistance is given by this expression, 6, you know, 1, 2, 3, 4, 5, 6. Huh? Pi is that 3.14 or 22 by 7, whatever approximation you prefer. Eta is viscosity. Viscosity is, think about, I'm going to make other videos on that, but for now, viscosity is about the thickness of the fluid or the ease of flow, kind of. So take water and pour it on the surface of table. It flows easily. But if you pour honey, it doesn't flow that easily. So if it doesn't flow that easily, it has more viscosity. So whatever that is, don't worry. So all the point is the fluids have their viscosity. Air will have some viscosity. Water will have some viscosity. And in a given situation, you will be given here. So this is falling in air. So viscosity of air, which will be given to you, which is a constant. Radius and uppercase, lowercase might confuse. So I'll write it in uppercase here. So radius of this object times velocity. Now that's something interesting, because when I spoke about this case, it is dependent on the normal force and the roughness. It doesn't depend on how fast the box was moving. But here the air resistance depends on velocity. This is velocity. V is velocity. So when this raindrop starts falling down, there is no velocity, there is no air drag, there is no air friction. So as it falls down faster and faster, the air drag is increasing. Very interesting thing here happening. I mean, the friction force is more if the velocity is more, and that is the key to terminal velocity. So let's glue all this together. So let's take a falling object and see what are the forces acting on it. So there is an object here, and I know there is a mass times gravity. Let me pull this down so that I have more room here. So let's say this is an object. There is mg going down. Mg is mass. Mass is volume times density. So density of the raindrop, I'll write it as drop. So this is the raindrop times the volume of the raindrop, which is 4 by 3 pi r cubed times gravity, right? That's the mass times gravity. So density of drop, because you are trying to find the mass of the drop. Now there is also a air drag. Now air drag we saw is simply 6 pi eta rv, where v is the velocity. Now there is a buoyancy force. Now how much is the buoyancy force? Buoyancy force is the weight of the fluid displaced. Weight of fluid displaced, fluid is air here. So air, the density of air times the volume of air displaced, which is same as the volume of this raindrop times gravity. So that is density of air times 4 by 3 pi r cubed times gravity. So there are three forces. So when it starts to fall down, this is some value and this is some value which is fixed. And this is 0 to start with. So there is a force going downwards more, and this one is lesser. That's why it's falling down. So buoyancy is less than mg. So mg is more, buoyancy is less. So it starts to fall down faster, faster, faster. But wait, what happens that is as it goes faster, faster, this kicks in and it starts increasing, increasing, increasing. So as the drop is falling down, increasing its velocity, this does not change, this does not change, this starts to increase. And at certain point, this will be so much that the yellow plus maroon equals to white. And there it is. The forces have balanced out. If there is no force, there are three forces, but there is no net force because this white equals to maroon plus yellow. So there is no net force. Force is zero, acceleration is zero. That is when the terminal velocity has been reached. Again, very interesting, right? So as it goes down, this does not change. It was bigger than the maroon. So this does not change. This does not change. This starts increasing because as it is going down faster, 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 velocity increases. This yellow portion increases, increase. At certain point, after falling certain distance, this will be so much that white is equal to this plus this. Now there is no more acceleration. The water drop is going to fall down with a constant velocity. And when will that happen? When this is equal to this plus this. Now this is a piece of cake. I'm not going to solve this for you. Come on, you are NSEP students. You can easily solve this. You plug in this minus this is equal to this, or just do this. So rho drop, I'll write D for short, drop 4 by 3 pi r cubed times of gravity should be equal to rho of air 4 by 3 pi r cubed times gravity plus 6 pi eta rv. Now obviously pi all cancel out. You cross out these pi's and then you bring this part here. You bring this part here and then you divide this part here. You get the expression for terminal velocity. I would like each student here to solve this and put it on the Telegram channel in the videos comment box, or maybe you can put it in the YouTube itself. So post your solutions here. All you have to do is solve this equation, and that is all. So wasn't this really very easy? I mean, terminal velocity. We have been looking at parachutes, we have been looking at raindrops, and the key to the constant velocity is simply the fact that the air resistance keeps increasing with the velocity. I will bring more such videos here. Do like, share, and subscribe this video. And by the way, if you want a paid course, we have launched NSEP 3, Module 3. What is that? So we started NSEP course with a 5 module series. We have already completed these 2 modules. We are starting this later in few days from now. Very soon, 16th of May is the start of this batch. So mechanics 3 as in module number 3. So even if you have not done module 1 and 2, that's fine. As soon as you have, as long as you have Josh and energy and you have determination to work hard, I'm with you. I'm going to provide you free videos for this. So you can join this also. And this one is mechanical properties of solids, fluid mechanics, thermal engineering, simple harmonic motion, waves. All this is 11th portion. And then we start 4th and 5th module, which is the 12th portion. So our scheduled classes are Monday, Wednesday, Friday, 6 to 7:30 p.m. But we will have extra classes as and when needed. Sunday is going to be your test day. You also get assignments on Telegram group, not channel, group, where you can also type. You can type your doubts are cleared. So all that is part of all this. And what you pay for that is module 3 is 2500 minus 10% only if you apply this coupon code VS Pro 1. So that price reduces by 250 rupees. But the good part is if you buy module 3, 4, and 5, that is 2500 times 3 is 7500, you get a 1000 rupees discount. So 6500 rupees minus 10%. So it's not like you are getting this offer, you won't get this offer, you get both the offers, right? So this will be what? 6500 minus 650, 5850 for the 3 modules here. Plus, we'll give you the free recordings of the previous modules. You get the doubt clearing, you get a Sunday test and everything. So if you need any help, you can contact our team member Ayush. He's going to help you. This is the phone number 80502 91657. So you can call Ayush or you can click on the link below and you can enroll in these batches. So Dhruv did it, Aditya Avnish did it, you will do it. All you need is determination for hard work, commitment, and always say, I will do it. So I'll see you soon with more such videos. Till then, beta, keep up the high Josh. Bye bye.